So in this video, we are going to be looking at finding equations of absolute value graphs, and this is what we did in class on 4/4/2013. And this is for anyone that missed class today, or if you were in class and just want a refresher, this video will help. So to start off, we are going to be trying to find the equation of this red graph. Now, before looking at it, let's first graph something that we know, which is the equation y is equal to the absolute value of x. And we know for this equation we start at 0, 0, and then we go up 1, 1, 2, 2, 3, 3 with a slope of 1. And in the other direction we go negative 1, 1, negative 2, 2, negative 3, 3. And that has a slope of negative 1. So when we're starting to look at this red graph, we can tell that the slope of the lines here and here have the same slope as this equation right here. Y is equal to the absolute value of x. Because we can see that we're going over 1, up 1, over 1, up 1, over 1, up 1. And in the other direction we're going to the left, over 1, up 1, over 1, up 1, over 1, up 1. And this is going downward, so it's going to have a slope of negative 1. And this side is going to have a slope of 1. So now that we've established that the slope of the red graph is the same as the slope of this graph right here, all we need to do is look at how this red graph is being shifted, And we know that it's being shifted to the left 2 spaces. And as we observed with our sliders last night, that when the graph is being shifted to the left, the c value is being changed. So we know that y is equal to the absolute value of x plus c. And something is going to be this c. You're going to get something for this c value. And because it's being shifted to the left 2 spaces, this c value is going to be plus 2. Now, why does this work? Well, this point, vertex right here, has the point negative 2, 0. And if we plug these 2 points in to this equation right here, we'll prove that this works. So y is equal to absolute value of x plus 2, and plug in 0 for y and negative 2 for x. And we get the absolute value, or 0 is equal to the absolute value of 0. Now we're going to look at a different graph, and we see that this graph, same with our other one, has a slope of 1 and negative 1 on both sides. And we can see it matches with our graph y equals the absolute value of x. The only thing different about this blue graph is it's being shifted downwards 3 points. So it's going down 3 spaces. And if you can recall from our slider work last night, we know that the whole graph, every single point in the graph is being moved down, and the variable that changed that was the d variable. So we know that the equation for this blue graph is y is equal to the absolute value of x, because we know that the slopes are the same as our original equation. And if every single point is being moved down 3, we're just going to subtract 3. So our equation of our blue line is y is equal to the absolute value of x minus 3. And we can check this by looking at the vertex of this blue graph, which is 0, negative 3. And to prove it to you, we'll just plug in. So we get 0 is equal to the absolute value of negative 3 minus 3, and the absolute, which is equal to 3 minus 3, which is equal to 0. So we know that this works. Our third graph is similar to the other two, whereas we know the slope is 1 in this direction and negative 1 in this direction. So we're going to start with our base of y is equal to the absolute value of x. But now our vertex is at a different point. It's at the point negative 1, 3. So to plug it into our equation, we know that y is equal to the absolute value of x plus 1, because that's going to move our graph over to the left 1 space. And then we're going to add 3 because it's moving our graph up 3 spaces. Now our last graph is a little bit different, but let's start with something we know. We know how to graph this equation so that the vertex is being moved over to the right 3 places. The point of our vertex is 3, 0. So we know that to start off with, the equation of this line is y is equal to the absolute value of x minus 3. Because that's going to move our whole graph over 3 spaces. Now the next thing we have to look at is the slope of these lines. And we know that over here, the slope is going to, well, to figure out the slope, we know we're going over 1 and up 2 to get to the next point. Over 1 and up 2, over 1 and up 2. So the slope of this line is 2. And in the other direction, we're going to the left 1, up 2, over 1, up 2. So the slope of this line is negative 2. In order to add this slope to our equation, all we have to do is we're going to take each point and multiply it by 2. So if this green line is our y equals absolute value of x equation, we know that this point is being multiplied by 2 to get there. This point multiplied by 2 to get here. This point, this point being multiplied by 2 to get up here. So our new equation is going to be y is equal to 2 times the absolute value of x minus 3. And that should be an absolute value, not a parentheses. The final way I'm going to prove it is just to make a table, x, y. If this is our equation right here, let's just plug in some points. So when y is equal to 6, we know that x is going to be equal to 0. 0 minus 3 is negative 3. The absolute value of that is 3 times 2 is 6. Now that was this point right here. Another point I'm going to try is this one right here. If x is 5, let's plug it into our equation. 5 minus 3 is 2. Absolute value of 2 is 2. 2 times 2 is 4. And we know that that's correct because this point right here is 5, 4. So we're able to go back and check our work. And there you have it, the ability to find the equations of absolute value graphs. Thanks.